All right, for Chapter 2, Lesson 1, we will be expressing rational numbers as decimals and decimals as fractions. A rational number is a number that can be written as a fraction. All right, so we'll talk a little bit about this chart here. Okay, looking at this chart, you see the inside here, whole numbers. That includes our 0, 1, 2, 3, 4, all positive numbers, including 0. Integers, that includes our negatives, and then once we get out here to rational numbers, that's our decimals, our fractions, anything that can be written as a fraction. So we think of as 0.3, well, we can write that as 3/10. Okay, and if you can write it as a fraction, we will call it a rational number. Okay, think rational, the key word in there is ratio. Okay, and another word for ratio is fraction. Okay, so rational number, rational means ratio, and a ratio is a fraction. Okay, so it kind of helps us remember there. So something that is not a rational number, to kind of give you an example, this would be an irrational number, would be like the number pi. And the reason pi is irrational is because it never terminates and it never repeats. Okay, if you have a repeating decimal like this one up here, we can actually write that as a fraction. Okay, so like 0.4 repeating equals 4/9. Okay, if you take 4 divided by 9 in your calculator, you'll get 0.4 repeating. We can write that as a fraction. Or if we get a number that terminates, we can always write a terminating decimal as a fraction. Like if we have 0.237, we could write that as 237 over 1,000. Now, we might be able to simplify that fraction. However, the bottom line is we can write it as a fraction. Okay, so we can write a terminating or repeating decimal as a fraction, but if the decimal does not repeat and it does not terminate, we call it an irrational number. All right, so we have our place values here. Okay, we have our thousands, hundreds, tens, ones, and then we have our decimal point. Whenever we see the decimal point, we say the word and. Okay, and then we have tenths, hundredths, thousandths, and 10,000ths. Okay, so it's important to understand these numbers, these words to the right of the decimal point, because if I have, let's say I have 0 and 1/10, so I have 0.1. Well, you simply write that as 1/10, okay, because all you say is 1/10, so it's 1/10. Now, if I had, let's say, 12 hundredths, well, then I would simply write 12 over 100, and maybe we'll write the 1/10 here. Okay, and then if I had 123 thousandths, then I would say 123 over 1,000. So if you know your place values, it's really easy to write it as a fraction, because if you're saying 2 hundredths, you just simply write 2 over 100. All right, so the makeup of a fraction. This right here is our whole number. All right, this is our numerator. And this is our denominator. Okay, the whole number represents how many wholes. So if I have like 1, 2, 3, 4, I have 4 whole circles, and then I have another circle that's split into 25 equal parts, but only 13 of them are filled up. So that's just under half. So it'd be like if I had a circle here, and maybe I had just under half of that circle shaded. Okay, that would maybe be okay. I have 4 and 13/25. Now, we can always regroup these. The bottom number tells us how many you need for a whole. How many you need for a whole. Okay, the numerator is like the leftovers. Okay, how many extras do we have? Extras we have. Okay, it's kind of like when you divide, that'd be a remainder. Okay, that's another word you could think of as the remainder. All right, so they're the leftovers or the remainder. Denominator tells you how many you need to make a whole. So, we would need 12 more pieces to make 5 whole. All right. Okay, so it says write 1/16 as a decimal. Well, in order to write it as a decimal, we simply need to just get our calculators out, and we need to do what the problem says. Okay, this says to take 1 and divide it by 16. So if I do 1 divided by 16, all right, I get 0.0625. So if you do this in your homework, it's okay to use your calculator, but I want you to say 1/16 equals 0.0625. All right, write the original problem. It is okay if you use your calculator. Now, we don't want to round anything because 1/16 is exactly 0.0625. I don't want to round anything here. Okay, now it says write -3 and 2/11 as a decimal. So we have 3 whole. All right, so we're going to say -3 and then we need to figure out what the fraction part is. Okay, so I'm going to do 2 divided by 11, and then it's 0.1818181818, okay, and so on. You see it repeats, but the numbers that are repeating are the 1 and the 8. So all you need to do is write one set of numbers. You can just write 1, 8, and then draw a bar on top. We call that bar notation. What that means is the 1 and the 8 are going to repeat. You do not need to write any more numbers. Actually, it's not appropriate for you to write any more numbers other than the ones that repeat. All right? Now, write 5 and 1/9 as a decimal. Again, if we write 5 and, all right, then we go to our calculator, we'll get 1 divided by 9, and that equals 0.1 repeating. So just write the number that repeats. So that number is 1 and put a bar over the top. It's just 0.1 and it repeats forever. Okay. Take a notice here that 9 and 11 gave us repeating decimals. Okay. Repeating decimals are often with denominators of 9, 3, and 11. Okay, those are common ones. So if you ever see a 9 in the denominator, I would anticipate a repeating decimal. A 3 in the denominator, I would anticipate a repeating decimal. And an 11, I would also anticipate a repeating decimal. So it kind of just gets you prepared for what you should get. All right, in a recent season, New York Yankees shortstop Derek Jeter had 6 hits in 22 at-bats. To the nearest thousandth, find his batting average. So if he had 6 hits in 22 at-bats, so he's 6 out of 22, then we need to calculate his batting average. So you just simply need to take 6 and divide it by 22. You can jump on a calculator to do that. All right, and so you see we get 0.272727. All right, now normally we would just write 0.27 and that's repeating. Now with baseball, in baseball, if you're ever watching a baseball game, they almost always show 3 digits. So if I write 0.2727, take a look at the 7. The 7 is greater than 5, so it's going to make your next number go up. So his batting average would be 273. Okay, and this is what we would say Derek Jeter's batting average is. Okay, but it is okay, for math, we're thinking, well, it's 0.27 repeating. Yes, but if we're talking about baseball, we're going to list 3 digits, and we'll always round according to the next number. So if this is a 5, 6, 7, 8, or 9, we'll round up. If it's a 0, 1, 2, 3, or 4, then we can round down. All right, so now it says write it as a fraction. Now, if you remember back when we were doing our notes, I told you it's important to know your place values. Okay, if I read this is 3200, so simply you write 32 over 100. Now, it's a good idea to always simplify your fractions, okay? Both of these are even numbers, so if I divide them both by 2, okay, if I can divide by 2 and divide by 2, I'm going to get 16 out of 50. And both of those are even numbers, so I can divide by 2 and divide by 2, and I'll get 8 out of 25. And I can't simplify that anymore So that would be my final answer. Whenever you write a fraction, it is always important to simplify the fraction. All right, so it says write -1 and 55 hundredths. So I'm going to write -1 and 55 hundredths. Okay. Now we can simplify this here. Let's divide them both by 5 since they end in 0 and 5. All right, so we can say -1 and 11 20ths. Okay, and I can't simplify that anymore, so I would be good. Again, just please remember, simplify your fractions. Simplify them. Even if it doesn't say to simplify it, always simplify your fractions. Now here it said -1, that's your whole, so always put that in the front. All right, now to write a repeating decimal as a fraction, we have a few steps here that we need to go over. All right, so let's take a look at this here. First thing you need to do is assign a variable to the repeating value. All right, so we had a kind of an error here. Assign a variable to the repeating value. All right, the second step we need to do is multiply each side by a power of 10. The power of 10 depends upon how many numbers repeat. So if one number repeats, you can multiply by 10. If two numbers repeat, multiply by 100. If three numbers repeat, you multiply by 1,000. Okay, so that kind of gives you that idea. And then your final step is subtract step 1 from step 2. So you'll have step 2, and then you subtract step 1 from it. Okay, so let's take a look at an example here. All right, it says write 1.7 repeating as a mixed number. All right, so we have 1.7 repeating. So we need to figure out how to get the 7 written as a fraction. Okay, so if we look at our steps, it says assign a variable to the repeating value. So let's say that n equals 0.7 repeating. Okay, so that's our repeating value. I'm going to assign a variable to it. Now, look back here. It says multiply each side by a power of 10. The power depends on how many numbers repeat. Now, what we have here is we have one number repeating. So, and actually, what I'm going to do here is I'm going to move this down a little bit. All right, and I'm going to, when I do the multiplication, because look at step 3. Step 3 says subtract step 1 from step 2. So it's important that you put step 1 down here. Okay, this is step 1. I put step 2 up here. So I'm going to multiply by 10. So I'm going to say 10n equals, if we multiply that by 10, it's going to be 7.7 repeating. Now we're going to subtract them. All right, now if I subtract, I'm going to get 9n over here. And when I subtract this, this cancels, so I get 9n equals 7. Now how do I solve for n? I divide both sides by 9. And so I'll get n equals 7/9. Okay, and so 7/9, remember, n equals 0.7 repeating, and now we're saying n equals 7/9. So what we just said is 0.7 repeating equals 7/9. Now we look back at our original problem, and so my answer is 1 and 7/9. Okay, 1 and 7/9 is how to write this as a mixed number. All right, so I know that might be confusing, but you know, be sure you can rewatch this video. You can look at your notes to see how we did that. All right, let's do another one here. Okay, it says write 0.5 repeating as a fraction simplest form. So step 1, write n equals 0.5 repeating. Now multiply by however many numbers repeat. So I'm going to say 10n equals 5.5 repeating. Okay, then we need to subtract. Why did I say 10n? Because only one number repeated. If two numbers repeated, like in this one, now we're going to multiply by 100. All right, now 10n minus n equals 9n. And this part here cancels, and I'm left with 5. Now divide by 9. And then n will equal 5/9. Okay, and before we said n equals 0.5 repeating, so basically 0.5 repeating equals 5/9. All right, what you're probably realizing is whenever you have the same number repeating, you put it over 9 and you're good to go. But I still want you to practice this. I want you to show this work. So the answer then is 5/9. Okay, and that is our answer for writing 0.5 repeating as a fraction in simplest form. All right, so write 2.15 repeating as a mixed number. So I know I'm going to have 2 as a whole number. What I need is I need my fraction. So let's go with 0.15 repeating, and then up here I'm going to say n equals. Now 2 numbers repeat, so I'm going to say 100n equals well actually I'm going to say 15 because I got to move the decimal place twice, right? Multiplied by 100, 15.15, and that decimal still repeats. Now when I subtract it, I'm going to get 99n equals, now the repeating part here cancels completely and I get 15. Divide both sides by 99 and I'm going to get n is equal to 15 over 99. Now I know just by looking at these I can divide both of these by 3 and I'm going to get 5/33. Okay, and I can't simplify that anymore, so I'm going to say 5/33. So 2 and 5/33 equal the same thing as 2.15 repeating. Now, what could you always do here at the end? You could always check. Like, so let's check our this example here. Let's do 5 divided by 9. Then we get 0.5 repeating. Now, notice here it changed to a 6. That doesn't actually mean that it goes to a 6. It's just my calculator rounded it at the very end. They rounded it up. Okay, now let's say 5 divided by 33, and we get 0.151515. Now look at this, 0.15 repeating. Okay, so it works, and you can check that with your calculator. All right, that's our last example here. I know that this is a tough concept for you to learn and for you to understand. Be sure to, feel free to rewatch this video and make sure you check over your notes when you're doing these types of problems in your homework or on a quiz or test.